So guys, here we are for a new video. In this video we are going to see how to solve another wind problem. That kind of wind problem where we have a true track, we have a wind vector, we have a true airspeed, and we are asked to find out the ground speed and true heading. So let's write down a typical exercise where we can face the AIS exam. True track 360 degree, wind vector 205 degree and 50 knots is the intensity of the wind, and then true airspeed. True airspeed, let's say 227 knots. And we are asked to find out ground speed and our true heading. Solving this kind of problem, the first value we're going to find out is our drift. Let's see how to solve it now and how to find out it. Sine of, and this is the first operation we have to do, is to consider of our true track and our wind vector and to subtract one to each other. So 316 minus 205 degree, and we get 111 degree. Okay, so to get out the drift we have sine of 111, then we have to multiply it for 60. 60 is a fixed value, so in this kind of formula is always the same value. Then we have to multiply it for the intensity of our wind, that, as we said, is 50 knots. At the bottom of our fraction we have the true airspeed, that is 227 knots. Let's see what comes out. Sine 60 for 15. Here we are. So our drift is 3,7014 degree, and we have our, and this is our drift. Later we are going to see if it's a left drift or if it is right drift, and if we have to add or subtract to our true track in order to get the true heading. But for now let's use the drift to find out the effective thrust and the ground speed. So second operation is the effective thrust. Effective thrust is the cosine of our drift, so 3.7014 degree, and we have to multiply this value for our true airspeed, that is 227. Let's see. And we can see that our effective thrust is 226.6739. The third operation is to see if we are the intensity of our headwind or our tailwind, and we can get this value with this operation, cosine of the difference between our true track and our wind vector, that is, as we saw before, 111, and we have to multiply this one for the intensity of our wind vector, that is 50 knots. Let's see, cosine of 111, and we multiply it for 15, and here we are. So minus 5,3755 knots. Now we have to consider that if we have a minus, we have a tailwind, so we have to add this value to our task to to find out our ground speed. If we have a plus, this means that is headwind, and so we have to subtract this value to the effective task to find out the ground speed. In this case we have a minus, means tailwind, means we have to add this value to the effective task. So let's see the result. And here we are, 232,0494. So rounding our result, we can say that our ground speed is 232 knots. Last operation is to see if we have a left drift or right drift. Let's see. And so if we have to add or subtract to our true track. I use this way to visualize the situation. I consider the true track, that is 316, so let's say it's like this, and our wind vector that comes from 205, so more or less like this. So if our true track is like this and wind is coming from the left side of our aircraft, we can say that our heading is more or less like this. So wind is impacting on the left side of the aircraft, and the result is a true track like this. So this means that in this case the value of our drift must be subtracted to our true track in order to get the true heading. So the last operation is this one. And the result is 312, and so this is our true heading. That's, as I said before, is the result of 316 minus our drift, that is 3°,714. Okay, this is all for this video. I hope you enjoyed, and I hope it can be useful in order to face your exams. If you like this video, please thumbs up, and if you have any question, write down in the comment below the video. Thank you for your attention, and see you for the next one.